Alright, so if you take a look at the JavaScript runtime environment, we have the JavaScript engine, which has the call stack and the heap memory storage. Then there are the web APIs that are specific to the browser that expose utilities like the DOM API to manipulate HTML and CSS documents, or the fetch API that acts as an interface for sharing resources across the network, or even something like the setTimeout method that lets you add some delay before performing an action. Then we have the callback queue that stores the callback functions sent from the web APIs in the order in which they were added. And finally, we have the event loop that constantly monitors the state of the call stack to see if it's empty, and based on that, it will grab a callback from the callback queue and put it into the call stack to schedule it for execution. So a typical flow will go like this. Let's say there's a script that has a console log statement, a function with an API call, and a function without one. The first thing that gets added to the call stack when the file loads is the global execution context. In simple terms, an execution context is the part of the script that is currently being executed. So it starts from the top, which means the global scope is executed first. Now inside this global context, it will find the console log statement, so that gets entered in the call stack, and since it essentially takes no time to run this statement, it executes it and removes it from the stack right away. Then it looks for function calls, not function expressions. So on this line, it finds the API function call. Since it uses the web APIs, the callback function will be moved to the web APIs block where it will get executed. This function will now be removed from the stack, and finally, it comes across the regular function call. It will again add it to the call stack, and this time, since there are no web APIs, it will just execute it and remove it from the stack. If the callback function from the API function is done with the execution, the result would be stored in the callback queue, and the event loop will keep checking when the call stack is empty. Since it is now empty and there are no other statements to run, it will send the callback result back into the call stack, execute it, and eventually remove it from the stack. Now, why did I explain you all this for a video which is titled as Web Workers? You see, even though JavaScript is single-threaded, it handles the asynchronous operations well without blocking the main thread. But what if the code that is blocking the main thread is not an asynchronous operation? What if there's a while loop that has an edge case which makes it run forever? Your call stack will always be occupied with this loop operation, and if there are any items waiting in the callback queue, they'll stay there forever. Now what if we could offload these potentially thread blocking tasks to a separate worker that does not run on the main thread? You can already see where this is going. Yes, I am talking about web workers. Now web workers make it possible to run a script operation in a background thread separate from the main execution thread of a web application. The advantage is that heavy processing can be performed in a separate thread, allowing the main thread to run without being blocked. On a side note, by separating heavy tasks into web workers, the way you organize your code also improves. This separation simplifies code maintenance and promotes a more modular structure in your code base. If you have watched my series on multitasking with Node.js, there we used worker threads, worker pool, cluster module, PM2, all sorts of tools to multitask. In this video, you'll find a lot of patterns very similar to the worker threads that we used inside Node.js. So if you have watched that series already, this is going to make much more sense to you, but even if you are new to this concept altogether, I'll try to keep it as simple as possible. Now JavaScript provides two types of web workers, dedicated and shared. The dedicated workers are specific to a single instance of a web page. They can communicate only with the page that spawned them. Dedicated workers are ideal for scenarios where a particular task needs to be performed in the background for a specific web page. Unlike dedicated workers, shared workers can be shared among multiple web pages originating from the same domain. This enables concurrent processing of tasks across multiple pages, promoting better resource utilization and intercommunication between different web pages. Let's consider an example of a dedicated web worker in JavaScript that performs a computationally intensive task. And by computationally intensive, I mean this horrible implementation of calculating prime numbers.
Kill it, okay? Just kill it.
We calculate the prime numbers from 2 to 100,000 in the worst possible way. Each number will divide itself with every other number that's smaller than itself to see whether if it's divisible or not. Once the iteration is complete, it returns a list of prime numbers. Now if I run this inside the browser, you'll see that the button does not render on the page until the calculation is completed. So if I go to localhost, you'll see that only after this execution completed did the page load. This is what I meant by blocking the main thread. Let's actually add one more 0 so that we get an evident delay. Yeah, you'll see that now it's taking a lot of time to render the button, and the prime numbers are also not present inside this console. So until and unless this calculation is not done, we won't be able to see the button here. Now to handle this, let us use a worker. So we'll create a new worker instance, and this worker is going to do the calculation for us. So I'll just create a file called worker.js. Inside the HTML file, inside the script section, I'll first create a worker instance. So const worker, and we'll use the worker class. And inside this, I'll just pass in the name of the file. Now inside the calculate primes function, we'll use the post message method that is present on this worker instance. So this will notify the worker to start the calculation. So I'll just use worker.postMessage, and inside this I'll just pass in start for now. At the very end of this script, I'll also add an onMessage event listener. So anytime we get a message back from the worker when the calculation is done, we can just simply print it out inside this. So onMessage, the data is going to be present inside this event object. So I'm using event.data. And now we can simply move this entire calculation inside the worker. So I'll just copy this, and inside the worker, I'll create an onMessage event listener inside this worker as well, because inside our main script, you will see that we have the post message method here on the worker instance. So whenever we send a message from this script to the worker, one way of getting it inside this worker is by using the onMessage event listener. So I'll use onMessage, which will have an event, and I'll copy the whole calculation here. Instead of returning this primes array, I'll just simply use post message. Now these workers run in their own isolated environments. So for this worker, the self keyword will act as the global variable. This global context is going to be different from the window that we have inside this script file. So if you try to access the global instance inside this worker file using the window keyword, you are going to get an error. Actually, I think I don't even need this. We'll see what happens if we don't have the self keyword, but I'm pretty sure that we don't really need this. We can directly use the onMessage method inside the global context of this worker instance. So yeah, let's just go with it. Now I'll just save both of these files. Now if I go back to the browser, there should be no blockages. If I refresh this, you'll see that the application does not really take that much time to make the prime number calculation, because it is being done on a different thread, and the UI thread is now free from the heavy calculation. Now the reason why this is called a dedicated worker is because this worker works only for the script that created it. Any other script inside this project won't have access to this worker instance. So if you have several scripts and each script for some reason has a thread blocking task, then you'll need to create multiple workers. This is where shared workers come in. Now the goal here is still the same. It is to offload heavy computation to a worker thread. But this time we can access the worker instance from different pages. The only catch here is that each page that will access the worker needs to have the same origin, which is a combination of the domain, the protocol, and the port. Alright, so let's create a shared worker. Inside our index.html file, we'll use the shared worker class instead of the worker class. One big difference with the shared worker is that you have to communicate via a port object. So this port object is an explicit port that we open so that the scripts can communicate with the worker. In the case of dedicated workers, this is done implicitly. Now to start the port connection between the script and the worker, we can use the onMessage event handler. There's another option to do this explicitly, which is by using the start method. But in case of onMessage, not only does this help us with our callbacks, but also implicitly create a connection, so it's much more convenient. So Instead of just using the post message, we use the worker.port to send the message. Similarly, we'll be using the port to receive the message from the worker. Now inside the worker as well, we'll have to make some changes. First, we use an onConnect handler to fire the code when a connection to the port happens. So basically, when the onMessage event handler in the parent thread is set up, the onConnect handler will fire. So we'll need to create an onConnect handler. This will again have the event object, but I'll call it E instead of event because we already have that inside the onMessage handler. I'll just copy the whole thing inside. We'll be using the ports attribute of this event object to grab the port and store it inside a variable. The rest of it is more or less the same. Again, the communication happens via a port, so we'll just have to add it over here and also for the post message method. Now if I run this in the browser, you'll see that everything works as expected. Now let's create another script that will use the same shared worker for some other calculation. So I'll create index2.html. I'll just copy the whole script from the first HTML. Instead of sending start, we'll be sending start2 so that the worker will be able to distinguish between the scripts. Inside the worker, I'll separate this calculation by an if statement. So if event.data is equal to start, then do this calculation. Else if event.data is equal to start2, then just simply post a message saying that it's a heavy calculation. Just imagine that this also is a heavy calculation. I'm not going to write any other function for this. Now if you go inside the browser and open up index2.html, you'll find the console log statement that is coming from the same worker. So we are essentially sharing this worker from two different scripts for two different calculations. One more side note, if you're trying to use the console inside the worker, it might not appear in the global console window. You can go to this URL and over there you'll have the option to open up the console dedicated to the worker. And with that, we have covered the basics of web workers in JavaScript. They are a powerful tool for improving web application performance by leveraging multithreading and background processing. You can do a lot with these workers, like for instance, if you want one tab of your app to communicate with another tab, a shared web worker could do that pretty easily. It might not be the most efficient way of doing so, but it certainly is possible. Anyway, in the next video, we'll be taking a look at another type of worker, which is a service worker. So do subscribe for that. And yeah, I'll see you in the next one.